In this video, we'll discuss about coupling in AWS. So it is often recommended that we should be coupling our services in AWS in a bit of loose manner so that one failure of service does not affect the other one. We can have a asynchronous communication so that the network is not clogged or the process is not highly utilized. So that we can implement using loose coupling. So as application complexity increases, a desirable attribute of an IT system is that it can be broken into smaller, loosely coupled components. This means that IT systems should be designed in a way that reduces interdependencies. A change or failure in one component should not cascade to other components. So there are some topics which are defined um, in loose coupling, that is well-defined interfaces. So a way to reduce interdependencies in a system is to allow the various components to interact with each other only through specific technology agnostic interfaces. For example, RESTful APIs. In that way, technical implementation details is hidden so that teams can modify the underlying implementation without affecting other components. As long as those interfaces maintain backwards compatibility, deployments of different components are decoupled. Amazon API Gateway is a fully managed service that makes it easy for developers to create, publish, maintain, monitor, and secure APIs at any scale. It handles all the tasks involved in accepting and processing up to hundreds of thousands of concurrent API calls, including traffic management, authorization, and access control, monitoring, and API version management. Now, another thing that is related to loose coupling is service discovery. So, applications that are deployed as a set of smaller services will depend on the ability of those services to interact with each other. Because each of those services could be running across multiple compute resources, that needs to be a way for each service to be addressed. For example, in a traditional infrastructure, if your front-end web service needed to connect with your back-end web service, you could hard-code the IP address to the compute resource where the service was running. Although this approach can still work on cloud computing, if those services are meant to be loosely coupled, they should be able to be consumed without prior knowledge of their network topology details. Apart from hiding complexity, this also allows infrastructure details to change at any time. Loose coupling is a crucial element if you want to take advantage of the elasticity of cloud computing, where new resources can be launched or terminated at any point in time. In order to achieve that, you will need some way of implementing service discovery. So, how to implement service discovery? For a Amazon EC2 hosted service, a simple way to achieve service discovery is through the elastic load balancing service. Because each load balancer gets its own host name, you now have the ability to consume a service through a stable endpoint. This can be combined with DNS and private Amazon Route 53 zones so that even the particular load balancer's endpoint can be abstracted and modified at any point in time. Another option would be to use a service registration and discovery method to allow retrieval of the endpoint IP addresses and port number of any given service. Because service discovery becomes the glue between the components, it is important that it is highly available and reliable. If load balancers are not used, service discovery should also cater for these things like health checking. Example implementations include custom solutions using a combination of tags, a highly available database, and custom scripts that call the AWS APIs, or open source tools like Netflix Eureka, Airbnb Synapse, or HashiCorp console. Now, as you can see in the given diagram, we have asynchronous integration and synchronous integration. So, asynchronous integration is another form of loose coupling between services. This model is suitable for any integration that does not need an immediate response and where an acknowledgement that a request has been registered will suffice. If it involves one component that generates events and another that consumes, the two components do not integrate through direct point-to-point interaction, but usually through an intermediate durable storage layer. For example, an Amazon SQS queue or an streaming data platform like Amazon Kinesis. This approach decouples the two components and introduces additional resiliency. So, for example, if a process that is reading messages from the queue fails, messages can still be added to the queue to be processed when the system recovers. It also allows you to protect a less scalable backend service from front-end spikes and find the right trade-off between cost and processing lag. For example, you can decide that you don't need to scale your database to accommodate for an occasional peak of write queries as long as you eventually process those queries asynchronously with some delay. Finally, by moving slow operations of interactive request paths, you can also improve the end user experience. Now, the examples of asynchronous integration are a front-end application inserts job in a queue system like Amazon SQS. A backend system retrieves these jobs and processes them at its own pace. An API generates events and pushes them into Amazon Kinesis streams. A backend application processes these events in batches to create aggregated time series data stored in a database. Multiple heterogeneous systems use Amazon SWF to communicate the flow of work between them without directly interacting with each other. AWS Lambda functions can consume events from a variety of AWS resources. For example, Amazon DynamoDB update streams, Amazon S3 event notifications, etc. In this case, you don't even need to worry about the implementing a queue or other asynchronous integration method because the service handles this for you. Now, another thing that is related to loose coupling is graceful failure. Another way to increase loose coupling is to build applications in such a way that they handle component failure in a graceful manner. You can identify ways to reduce the impact to your end users and increase your ability to make progress on your offline procedures, even in the event of some component failure. Graceful failure in practice. So, a request that fails can be retried with an exponential backoff and jitter strategy, or it could be stored in a queue for later processing. For front-end interfaces, it might be possible to provide alternative or cached content instead of failing completely when, for example, your database servers become unavailable. The Amazon Route 53 DNS failover feature also gives you the ability to monitor your website and automatically route your visitors to the backup site if your primary site becomes unavailable. You can host your backup sites as a static website on Amazon S3 or as a separate dynamic environment. So this concludes the loose coupling concept in AWS and how it benefits while architecting the AWS infrastructure. So thank you for listening.